This is the first video in our new unit, which is algebra, and our first lesson is on patterns and rules. To complete a number pattern, we need some information. We either need a rule that describes the pattern, or we need enough numbers from the pattern that we can figure out the rule ourselves. Example 1 is an example where we're given the rule and asked to fill in some more numbers. So the rule says, times the first number by 3 and then add 2. So we can see we've started with 1, we've done 1 multiplied by 3, which gives us 3, we've added on 2 to get our second number, which is 5. So if we were to work out the next number in the pattern, we would do 5 multiplied by 3 plus 2, which gives us 15 plus 2. So the next number in our pattern is 17, and you could continue this on for as many numbers as you liked. Example 2 is an example where we're given more numbers and asked to figure out the rule on our own. So we could try a couple of different things. We could try to see if it's a multiple, so we could start with the first number and see if you can multiply it by something to give you the second one. So 1 multiplied by 3 will give you 3, but then if you have a look at the third number, 3 multiplied by 3 isn't going to give you 7, so that's not going to work. We could try multiplying by 2. So 1 multiplied by 2 isn't 3, so that's not going to work either. So now we might have to add something on. So if we stick with our multiplying by 2, if we multiply 1 by 2, we get 2. Then to get our second number, we can add on 1. So what we've tried at the moment is multiplied by 2, add 1. Now we want to check whether that's going to work with this example here. So then we go take our value, our second number in the pattern, 3 times 2 is 6, plus 1 gives us 7, so that one does work. Now just to make sure we found the right pattern, we're going to try it with the last two numbers. So 7 multiplied by 2 is 14, plus 1 is 15. So we figured out that the rule is the first number multiplied by 2 plus 1. To set out the information for different patterns, we use what's called an input and output table. So input and output tables can be thought of as a number crunching machine, like this little cartoon here. So one number goes in, something in the machine, a rule is applied, and then a second number comes out the other side of the machine. So in this example here, if we're following along with the wording, use the given rule to find the missing out numbers in this table. Add 3 to each in number. So what that means is, for example, if we're looking at this one here, a 1 goes in to the machine here. Inside the machine, 3 is added. Oops. And so what number is going to come out? That will obviously be a 4. So in here we would write a 4. If a 2 went in to our number crunching machine, inside 3 was added, so out the other side would be 5. And you could fill in the rest of your table, adding on 3 every time. Okay, so why is an input-output table useful? The idea is if we set up all of the numbers from our pattern, and then we can see it with its matching pair, so the number that goes in matched up with the number that comes out. If we see a couple of them in a row, we could be able to figure out what the rule is. So for class tomorrow, I would like you to bring in a table. So you're going to make your own input-output table using your own rule. So obviously don't tell anyone what your rule is, and then you'll show it to someone in class and hopefully they'll be able to figure it out. So what you need in your table is along the top, you'll need all of the input numbers. So input numbers are going to go in here. So these are your input numbers, 1, 2, 3, 4, 5 and 6. And then you're going to fill in some of the output numbers. We don't want to put all of them in because we want the people in your class to have to do a little bit of thinking on their own. So I've thought of a rule in my head and I'm going to put some of the numbers in. So I'm going to put a 2 in here, a 5 in here, and an 11 over here. So make sure you write down your rule somewhere so you don't forget, and then you're going to take your table into class and hopefully one of your friends can figure out what your rule is. Have a look at this table here and see if you can figure out the rule for this one too. Okay, here we have another example. So the cost of buying muesli bars is related to the number of muesli bars that are purchased, as shown in this table over here. So what we really have is another example of our input-output table. This relationship can be represented by a rule. Complete this sentence. The rule is something, the number of muesli bars, by, to obtain the total cost in dollars. So we want to be thinking about what's happening to our numbers. So we're looking at our input number here and what's happening to that number to give us our output number. Might have to look at a couple of the different pairs and hopefully you can see that each of them is being multiplied by 2. So now that we've figured out what our rule is, we can fill in the blanks. The rule is multiply. I'm not going to be able to fit that in, so I'll just do a times sign. So multiply the number of muesli bars by 2 to obtain the total cost in dollars. Okay, so what are the two variables in this relationship? So a variable is a quantity that can have varying or different values. So in our table over here, our two variables are the input number and the output number. So our two variables are number of muesli bars, so number of bars and cost. Okay, so what is the total cost of buying 2 muesli bars? We can look over at our table over here, and if you look at where it says number of muesli bars 2, this is the bit that we're looking at. So for 2 muesli bars, the total cost is going to be $4. And for 5 muesli bars, it's going to be $10. Okay, what's the total cost of buying 11 muesli bars? Now, this one isn't on our table, so we're going to have to use our knowledge of the rule. So we said that the cost of buying is the number of muesli bars we need times 2. So our solution for this one here, it should cost $22. And for 38 muesli bars, we're using the same rule, so 38 times 2, and our solution is $76. Okay, to obtain your answers to part C, was it easier to use the table or the rule? So for part C, when we were looking at 2 or 5 muesli bars, that one was just up in the table, so that was the easiest way. But for part D, we had to use the rule. How many muesli bars could you buy for $6 or for $34? Now this one's a little bit different. Our rule for this one is going to look like what number of muesli bars at $2 each will cost $6. So what we're really looking at is what number times 2 will give us 6. So we can figure out that 3 bars. will cost $6, and it will be using the same technique for the second one. So what number of muesli bars, still costing $2, will have us spending $34. So we're looking for what number times 2 will give us 34, and that's 17. So 17 bars will cost us $34. So these are the key ideas from today's video. Algebra is all about looking at number patterns and rules. A rule describes a relationship between two or more variables, and a variable is a quantity that can have varying or different values. For example, we were just looking at cost was one example of variable, and also number of muesli bars. So these would be 3 dot points that it would be really good if you could write them down in your notes.